In this video, we are going to consider derivatives and differentials of composite functions. Let me say now we have the following function z given by f of x, y, where x is the subfunction, let me call it g, which depend on t, and y is also a same function, then let me call it h. It depends also on t. When we check here, z is the main function which has two variables x and y. However, x and y are two subfunctions of z. Then out of this, let me say we want to find dz dt. When we check this problem, in the main function we do not have the variable t. However, t is contained within the two subfunctions of x and y. Then when you want to find dz dt, it means you are going to consider the diagram. Let me say this is z. Z is the main diagram or the main function. Z depend on x and y. Then this is x, this is y. Then when we check the subfunctions x and t, they only have one variable, which is t, which means x depend on t, also y depend on t. Therefore, when you want to find dz dt, it means you're going to find the partial derivatives by following this procedure. You'll differentiate z with respect to x first. It means you're going to have z dx, then you multiply the differentiation of x with respect to t. It means you'll have dx dt like this, then plus, then when you check y also depend on t and z also depend on y, then it means now we're going to have dz dy, and then you multiply by dy dt, dy dt like that. So in contrast to what we have, we can also look at the following composite function. Then let me call it z is f of x, y, and then x, let me call it g of u, v, and y, I can call it h of u and v. So this example, when you check, is a little bit different from the first example, because this one, the subfunctions has two variables, which are u and v, and then in the first we only had one variable, which was t. So this one we are going to find dz with respect to u, or dz du. We can also find a dz dv out of this. Then we draw the main diagram. This is the main diagram. Z is the main function. Then when we check, z depend on x and it also depend on y. Then out of this, x as the subfunction, it depend on u and v. Then x depend on u, it also depend on v. Also as y, when you check, y also depend on u and v. It means we're going to have u, and then this side we also have v like that. Then when you want to find the z du of this composite function, it means you follow the procedure dz du. Then you follow only the string which contain the variable u. Then it means we're going to have dz dx, dz dx, and then you multiply by dx du, dx du plus dz dy, dz dy, you multiply by dy du, dy du like that. Then secondly, we will look at dz dv, and then we'll consider dz dv. It means we are going to consider the string which contain the variable v though. So the one which contain the variable u, this time around we are not going to look at. So it means we will have dz dx, then you multiply by dx dv, because we differentiate z with respect to v this time around. So it means we'll have dx dv plus dv dz dy, then dy, then you multiply by dy dv, then it means we'll have dy dv like this. So this information can be generalized as follows. So let me say now Z is the main function which has the variables x, y, and w like this up to the last variable. Then we have the subfunctions x. Let me say, let me call it g. Then x contain the variable u, v, and t up to the last variable. And then out of this we have y. Let me say y contain the variables. It will also contain the same variables as u, v, and t. Then let me call it h, u, v, t up to the last variable. And lastly we have w is the sum function of z. And then let me call this one q. And then I will say this one also contain u, v, and t up to the last variable. So out of this we can find dz, du. We can also find dz, dv, and lastly dz, dt. Then how can we go about solving this type of a problem? So this is what we are going to solve it. Then we'll have dz, du. We'll also have dz, dv, and lastly we'll look at dz, dt. Then let me use the following diagram. This is z as the main function, and then z depend on x, y, and w. It means this is x, this is y, and then this is w. And then the subfunctions x, y, and w, when we check, they all depend on u, v, and t, u, v, and t. So for illustration, let me just do this because they depend on common variables. I will bring them to the same point and say these three depend on u, v, and t. Then how then can we find dz, du? When you want to find dz, du, you have to differentiate z with respect to x, then you multiply dx, du, then you will have dx, du this time around, then plus dz, dy, dz, dy, and then you multiply by dy, du. Then we'll have dy, du. And lastly, because w also depend on u, it means we're going to have dz, dw, and then you multiply this by dw, du. So this is dw, du for dz, du only. Then however, when you want to find dz, dv, it means you have to forget about u and t, and then you consider only the stream which contain the variable v. Then it means we are going to have dz, the x, because x will depend on v, as well as y and w will also depend on v. And then for now, let us say we'll have dz, dx, dz, dx, and then multiply by dx, dv, then dx, dv, because we differentiate z with respect to v, and then plus dz, dw, dz, dy, I mean, dy, and then multiply by dy, dv, because we differentiate z with respect to v. It means now we'll have dy, dv, plus dz, dw, because w also depend on v. It means we're going to have dz, dw, and multiply by dw, dv, dw, dv. So and then lastly, when you want to find dz, dt, you follow the same procedure. You only consider the stream which consists the variable t. Then it means you are going to have dz, dx, you multiply by dx, dt, dx, dt, plus dz, dy, dc dy, and then you multiply this by dy dt, dy dt, and lastly we are going to look at the dz dw, then this will be dz dw, then multiply this by dw dt, dw dt. So this is how these differentials of composite functions can be generalized. Therefore, out of this, then we can solve some couples of examples. Then let me consider the following example. Let me say find du dt, given that u is x squared plus y squared, x is at squared, and y is given by 2at. We want to find u dt. When we check u is the main function, u is the main function, u is the main function, then the main function depends on x and y, x and y, and then out of this, x and y are subfunctions. However, x and y depend on a and t, but we want to differentiate the u with respect to t. Therefore, we don't have to consider the let or the variable t. Let me just use t like this. And then for approach, we are going to have du dt. Then it means we will have du dx, and then we're going to have du dx, and then you multiply by dx dt, dx dt plus du dy, du dy, and then multiply by dy dt, dy dt like this. And then from now it's a matter of differentiating what we have. So it means first we're going to differentiate the main function with respect to x. Then when we differentiate the main function with respect to x, we'll just have 2x, and then y squared is just a constant which can be considered to be 0. And then dx dt is from the subfunction x, which is equal to a t squared. Then we differentiate it with respect to t. It means we'll have 2a t like this, and then plus du dy. Du is the main function, it's from the main function, therefore we differentiate this function with respect to y. Then this time around we'll have 2y, and then we differentiate y, this is y, the sub function, with respect to t. Then this is just 2a like this. And then finally it means we are going to have 2 times 2 is just a 4, and then x at, and then plus 2 times 2 also will give us 4 y a. So this is all what we had to find for this type of an example. And then we can also look at another example for the sake of practice. Let me say now we want to find du ds and du dt, given that we are given that u is equal to x squared minus xy. This is the main function, and the subfunctions are x and y, and then x is given by s cos t, and y is given by t sin s. Then when we want to find du ds, you can draw the diagram starting with the main function u like this. Then we check u depend on x and y, will depend on x and also depends on y. However, x as a sum function will depend on s and t, But considering the question we want to find du ds, it means x must depend on s, also y must depend on s. And then when you want to find du ds, it means we're going to have du dx like this, and then this will be du dx multiplied by dx ds. Then this will be dx ds plus du dy du dy, and then this multiplied by dy ds, then this is dy ds. Then you can now differentiate the u with respect to x, where u is the main function. And differentiate it with respect to x, it means now you are going to have 2x minus y from this main function. Then you differentiate dx with respect to s. Where can you find dx ds? From the sub function x equals to s cos s. Then from this, it means you are going to differentiate with respect to s. Then you will have cos t like that. Then plus, let me just write it down here for the sake because of space. Then du can be found from the main function. Then differentiated with respect to y, it means we are going to have minus x. And then we also have to find the dy ds. Then from this subfunction y, and then we differentiate it with respect to s, and then we keep t as the constant. Then we differentiate sine s. It means we are going to have t cos s, because the differentiation of sine is cos. So that's it for the du ds. And then we also have to find the du dt. How then can we go about finding the du dt? The du dt is the same procedure. Out of this, we can just add t here or add t here, because x and y also depend on t. Then it means now we are going to have du dx will multiply by dx dt, dx dt plus du dy du dy. Then this is multiplied by dy dt, dy dt, like that. And then from this step henceforth, and then it means you are just going to differentiate what you have to differentiate. Then du dx is just the same, it will never change as from du ds. Then it means we're going to have du from the main function and differentiate with respect to x. You will have 2x minus y, then you multiply by dx dt. Then this time around, this is x, this function, then we differentiate it with respect to t. It means we're going to differentiate cos t, and cos t is minus sine t. Then it means you'll now have minus s sine t. And then plus du dy. Then when we check du dy is still the same as minus x. Then now we have to differentiate dy dt. Dy dt, this is y, and then now we differentiate it with respect to t, not with respect to s. It means we are going to differentiate t. The derivative of t is just 1. It means now you'll have the sign of s. That's it for this problem. Then I think we can look at one more example for the sake of practice. Then let me say we are given the following main function. The main function is given by u. U is x to the power to the fourth y plus y squared z cube, whereby the subfunctions x is given by r. This is r, the natural log e to the t. This is r. This is like r as e to the t, and then y is given by rs squared, and then this rs squared e to the negative t, and lastly we have z. Z is given by r squared as sin t, as sin t. So we want to find du ds. We want to find du ds given that the value of r is 2, the value of s is 1, and t is 0, like that. So when we check here, we want to find the u ds, where u is the main function which is dependent on x, y, and z. Then we can draw the diagram. This is the diagram. U is the main function. It depends on x, on y. It also depends on z. However, the subfunctions x, y, and z, they depend on r, s, and t, like that. However, by analyzing the question, we want to find the u ds. It means now we consider the string which contain the variable s. And then this one, x, will depend on s. Also, this one must depend on s, as well as this z must also depend on s. And then I will bring them to the same point. Then x will depend on y. Let me just use s like this. All right, and then how can we now go about solving this type of a problem, ds? So we're going to find du dx. Well, we have du dx, and then after that we are going to find a dx ds, like this. So this must be dx ds plus du dy, du dy, and then y also depend on s. It means now we are going to find dy ds plus du dz, and then multiply by dz ds. Then means now we have dz ds, like that. Then from now on, it's a matter of differentiating what we have here. It means first we are going to differentiate u with respect to s. U is the main function with respect to x. Then we differentiate with respect to x. It means we are going to have 4x cubed y. This is a 0 because it doesn't contain the variable x. That's it for du dx. And then secondly, we consider dx ds, and then x is the subfunction. Then we differentiate it with respect to s. It means we will have re to the t, like that. Then plus du dy, and then this is the main function. And then now we differentiate it with respect to y. We'll have x to the 4 plus 2y z to the third when we differentiate it with respect to y. Then we multiply by dy ds. Then y is the function. However, we have to differentiate it with respect to s. It means we are going to have 2r s e to the negative t, and then plus du dz. And then when we differentiate u with respect to z, then this was just a constant, it will be a 0. And then we differentiate this part with respect to z, we are going to have 3y squared z squared, and then we multiply by dz because z also depend on s. And then we have the the variable z. Then now we have to differentiate it with respect to s. So it means we'll have r squared sine t like that. So this is all we have to do for the UDS. However, when we are given the following values of r is 2, s is 1, and t is 0, it means we are going to substitute the values in the main differentiation, which means then now when r is 2, what is the value of x? When r is 2, we can find x from this. It means now x might be equal to r as e to the power t. However, they said r is 2, s is 1, e to the power t, t is a 0, which means then now we have 2 times 1, 2 times 1 is just a 2, and then e to the power 0 is a 1. It means the value of x is 2. And then we can also find y when r is 2, s is 1, and t is 0. Therefore, we want to find y. It means we're going to substitute r, s, and t using these values. It means now we'll have r is 1, then s squared, r is 2, we'll have 2, then s squared is 1 to the power 2, which is just a 1, e to the power 0, then this is also a 2, and then z can be found from this equation, the sub function. It is a r squared, and then r is given by 2, therefore 2 squared is a 4, and then we multiply by s is 1, and then sine t, we'll have sine t. However, t is a 0, and therefore if t is a 0, then sine t is also a 0. It means then now z is a 0, and then out of this, it means we are going to substitute the values in this equation, and then so that we can find du ds. Then now it means we'll have 4 x. What is the value of x? We have said that x is 2. It means now we'll have 2 to the third, then multiply by y. Y is 2 like that. Then we multiply this by r e to the power t. Then it means we'll have r. We have said that r is a 2. It means we'll have 2 e to the t. T is a 0. Then plus x. The value of x is 2. So it means we'll have 2 to the power 4 plus 2y. Y is a 2. And then z is a 0 to the third like that. Then since this is a 0, it means everything here within will be a 0. Then we multiply by 2 r. We have said that r is a 2, s and s is a 1, e to the power t, t is a 0, and then lastly we add this part. We will have 3 y. The value of y, we've said that is a 2 squared, then z is a 0, and then we multiply by r squared. R is a 2, is a 2 squared, and then the sign of a 0. And then the answer which we are going to get after multiplying this throughout, it means we'll have 2 to the power 3, this is 8, multiplied by 2, and then 2 times e to the power 0, and then this is just a 2, plus everything here, 2 to the 4th,